Hey everybody, take a look at this chart. This is a new benchmark that I've created, which allows models to compete in a translation task from English to a made-up language. Here is the full dictionary for this new language, which we are dynamically generating. And here are the text snippets we are testing on. These are the snippets from the book Moby Dick. And as you can see, this is the original text and this is its translation. Each one of these words are uniquely generated. There is no method to it, as in each word is generated randomly. So each one of these words in this dictionary is quite unique. So if you look at the chart again, you can see that this is quite a challenging task, and Gemini 2.5 Pro did best. GPT-5 Medium did second position. Now, I want to explain that in this test, we are sending these 500 word chunks to the model to translate it into this. Okay, this is how we are rating it. And we count each word and each word, and we count the accuracy by the amount of mistakes it made. For example, here, if you look, here, Grok 4 got 1481 out of 5,000 correct, because we are making 10 calls. There are 10 snippets, so a total of 5,000 words. That means it was accurately able to translate 29.6% of it. Now, the thing is, in this full dictionary, we have about 2,000 words, which are extracted from these 500 text snippets. So this dictionary, full dictionary, covers all the words that are needed. But the thing is that models were doing actually quite good with just this. So I artificially inflated the dictionary to 5,000 words, unique words, using this text.txt, which is I just copy pasted this from Gutenberg books. And our first file, and I named the files from A to E in progression, actually does the dictionary creation. By the way, all these files will be available at my Patreon. Link will be in the description or in the comment, depending on where you're watching this from. And as a surprise, towards the end, we're going to look at a JEPA implementation I have done and see how it is performing. This is an evolutionary algorithm-based system that is in this paper. JEPA, reflective prompt evolution, can outperform reinforcement learning. So I tried to implement this. So this will be another video. It's currently running, but towards the end, we'll take a look and see how it is progressing. So this is actually trying to create the perfect prompt to improve this translation performance for Sonoma Sky Alpha currently. That's what I'm running it on. Anyway, coming back to this, let's actually take a look at the model accuracy chart. As you can see, Gemini 2.5 Pro does the best. Then GPT-5 Medium. Actually, GPT-5 Medium failed to return the proper response format for a few, but that's still part of the testing. Flat Sonnet did 57%. GPT-5 Mini Medium next. Sonoma Sky Alpha is actually doing pretty good for it being a very, very fast and quick model. Grok 4 unfortunately didn't do so well. Grok Code Fast actually does pretty good, it being a coding model, really. I'm impressed. But all the other models like DeepSeek, Kimi K2, the latest version, GLM 4.5, Quen 3 Max did badly. And I also tested the latest Nemotron Nano 9 billion V2 from NVIDIA. That just didn't do well at all. So this first uh, script actually allows you to generate as many text word counts as you like. For example, here it can generate 10 word text snippets with its translations. It generates 10 of them. But since we also specify 200 and 500, it also generates these JSON files. So you can test it for different settings. And it creates a full dictionary, which uses all the words that are used to create these text snippets. It also creates an inflated dictionary to make it more challenging for models. You can set the inflated dictionary size. This will include all the full dictionary plus whatever else needed to top it off at whatever number you enter here, like 5,000. When I did the inflated dictionary, I can show you here that we were able to reach 52,000 tokens, meaning this is what we're passing to the as a prompt to the part of the prompt to the model. So this is also in a way a needle in a haystack test, right? So the model needs to take a look at these sentence and pick, for example, when. Let's take a look. If you copy when and then come to our inflated dictionary and paste, we see that we're going to find exact when. Oh, yeah, when is here. It's supposed to be QRANM. And as you can see, that's what the model has to find. So this is an interesting test. It not only tests needle in the haystack, but it also tests the model's capability to put this whole thing together. There's also a very detailed README if you do download it from my Patreon. So that is what the extract text snippet does. It creates these dictionaries, and then here's a quick Open Router file. Be able to call Open Router in async mode, so we can make parallel calls. And this C translation accuracy tester, you can enter any any list of models here. I actually forgot to put in OSS 120 billion, the open source model from OpenAI. That's too bad, actually. You can set a reasoning effort, and you can also set the JSON files here. I only tested the 500 words for this because that was the most challenging and the most meaningful percentages came out of this. By the way, this cost me like $15 to make, and in all the testing and stuff, actually almost like $30, $40. So I would appreciate you taking a look at my Patreon. These kind of tests aren't exactly cheap. Anyway, this translation accuracy tester, you just set your parameters here, retry. There's a retry mechanism, and then this is quite long, and it actually runs through and does all the testing. And at the end, we'll save it to comprehensive translation results in ranked, like Gemini 2.5 Pro. Succeeded the most. It got 3,600 words out of 5,000 correct. You get to see the accuracy here, which text JSON we have used. Second is GPT-5, so on and so forth. And also there's the detailed breakdown of like how many words were gotten correct or not for each model. If you actually scroll all the way up. Oh wow! Look at this predicted translation. Actually, what model is this? This was Nematron. It really ran crazy over here, and also here. Wow. Okay, I didn't even notice this. So you can actually see each model. You can. This is a very long file that has all the outputs from all the models, and then the create accuracy chart. You can pass in the results path, like right click, copy relative path or path, and paste it here with an R in front. And this will just create this chart. So if you do to run it for different types of models or in different configurations, you can create this chart. And here E, which we are not using, actually creates a subset dictionary. So instead of full dictionary, which includes, like for example, when you create this 10-word snippets, 200-word snippets, and 500-word snippets, the full dictionary contains all the words that exist in all three of them. The subset dictionary is designed to actually create only the word subset dictionary from a single JSON file. Because originally I thought this would be way harder, and so I wanted to create a dictionary, some simpler dictionary, but that wasn't necessary. But I have it here just in case if you need it. You can also include additional random words. You can set this to 0. This was to make it more challenging, but none of that was actually ended up being necessary. So this is very interesting. So in a nutshell, so we are passing the inflated dictionary and asking and passing it one of these sentences, of course, the 500-word version, and asking it to return the expected translation. This is how it works. And models did impress. Like I thought this is a perfect example of in-context learning, and they did really well. So these big models, Gemini and GPT, including, I mean, all of them really did respectable, but the top three did exceptional. Sonnet 4, GPT-5 medium. All of these is in medium reasoning settings. So let's come back here real quick. But before we do, I will make a separate video on JEPA, but all the code files here will be available at my Patreon, like I said. And if you do decide to become a paying patron, you will have access to over 400 interesting and useful apps, such as this one. Also, my exclusive videos and weekly meetings on Sunday. And I also offer consulting services. If you take a look at the membership tiers, you can see, and if this is something you're interested in, if you need help with your projects or if you want to learn something, if you want to get in touch with me, you can utilize that. Now, now just to end it, let's take a look at this JEPA. This is running. So this is a very preliminary, but this is a like I said, system which utilizes an evolutionary algorithm to try to improve the prompt. If you look at this iteration, like this was the prompt that showed the first improvement. And if you look at iteration 19, it's actually being increased. We can actually, so this is supposedly the best prompt. We just got a new one. Oh, it says 49%. So we can actually test this. Possibly we can try. Let's come back here. We can see that we are using Sonoma Sky Alpha, which was normally with just the generic prompt that I created, was at 30.1%. So let's actually do this. We can actually here create a system message parameter. Should be able to do this easily. Let's just do it. Okay, so let's put the system message here, and then we have to come back down here wherever we are making the call. Oh, I was putting it in the wrong file. Let me grab this. Come to translation accuracy tester, maybe at the bottom. Let's put this and come to, so this is just a prompt, and we are just passing a regular user prompt, but we can actually change this to also include a system prompt, and I will actually leave this empty at the end. So you can actually add your own. Um, or at a very simple one. So here we can comment out all of these except Sky Alpha, and everything else is set. I believe we can just run this. And if you come back to the chart, so Sonoma Sky Alpha did 31%, and supposedly uh, this prompt did 49%. We're about to find out. Yeah, interesting. So I think there's some issues with this JEPA implementation, but let's see if this will work. It's pretty quick. We'll be able to find out, and you'll be able to see how it's running. So when the script runs, it prints which dictionary we are using and which JSON file we are using and which model we're using. So let's just give it a moment. Okay, yeah, we got the accuracy result. We actually didn't do as well. Yeah, so this JEPA, we're gonna have to look more into it. So this did not work, but let's see. Let's remove the system message. Let's make it empty and then run it again to make sure we get, there's going to be some variability, right? I only run these one time. So there's going to be variability. So let's see what happens without the system message. Yeah, while we are waiting on this, it is important to run this several times, but it would have been too expensive. And I thought, well, you're running it one time, we get a rough estimate. I don't think these should vary wildly. Maybe 5%. Let's see what happens. Oh, wow. Actually, it got 13%. Well, that's interesting. So there's quite a lot of variability, maybe, or maybe adding the system message perturbed it. Let's test it again because we can see here in the original JSON that Sonoma did 31%. It got 15 600 words right here. It says I got all mixed up, but how many words? Like it only got 656 right. It could be because we are adding an empty system message. Part of it is due to variability for sure, but I wasn't expecting this much. And next, actually, while this is running, let's remove the system message altogether. And then run it again right after this. Because maybe, like I said, sending an empty message might be causing an issue. Okay, yeah, we got 30% with the system message being empty. Let's run this again with the system message completely removed. So this is more like it, 30%. So the variability seems more pulling it downwards. It's skewed to the downside, maybe a little bit. Well, I mean, this is probably a smaller model because it's fast, and but we'll find out. This is probably the new Grok 4.2 or something. I'm not sure, but it's really fast. Also, see, if you look at this JEPA, it does this candidate pools and it does reflective prompt mutations and things like that. Very interesting. I'll work on this and we'll make a video and also make the code available at my Patreon, like I always do. But that's for another video. Yeah, here we got again 29.5. Okay, for this, I will leave the system message off, but you can just add it. Just add a system message variable here, and wherever the prompt was, just update it right where you're passing the messages. So it should be pretty easy. Well, thanks for watching again. Take a look around at my Patreon, please. And don't forget that I offer consulting services as well if you're interested. And take care. Talk to you in the next video.